If you can dream it, you can build it. Dream of designing a device that will change our lives. Now imagine you can make it happen. Make it real. Make it fast and powerful. Make it intelligent and make it learn. Make it analyze and predict. Make it fun and creative. Make it look sharp and gorgeous. Make it friendly, user-friendly. Make it efficient and productive. Make it smart and connected. Make it prevalent and extensive. Make it secure and protected. Make it safer and autonomous. Make it sound clear and pure. Make it speak
and understand.
Make it free, truly wire-free. Make it sweat and stay in shape. Make it move and sense all around you. Make it grow and make it nourishing. Make it all happen with CEVA. CEVA licenses ultra-low power smart sensing and wireless connectivity solutions. CEVA's IP powers more than 10 billion devices worldwide. Dream it and make it with CEVA.
We will now get back to Nir Shapira, and he will introduce the PentaG, an IP platform for baseband processing to address the other side of 5G in small cells and user equipment. So over to you, Nir.
Thank you, Moshe. We will now discuss the PentaG, our holistic IP platform for cellular baseband processing. Just a second. Okay, so let's start with the short 5G terminal UE market status. So we see this, the UE handset market very much highly consolidated in both the silicon vendor perspective that we can see here, the very few silicon players, as well as the handset device vendors. So a few vendors, they dominate the market. We also see a significant trend of vertical expansion of OEMs to produce their own silicon. So it is known that Apple are working on a 5G modem. We know Samsung and Huawei have their own solution. And now the next in line is Oppo as well. We also see a significant 5G penetration throughout the first half of the decade. But still, even towards the middle of the decade, 5G would be no more than 50% of the total market, and it is expected to continue and growing until the end of the decade. So in light of this consolidation, where do we think we will see future opportunities in 5G? It is generally accepted that the run growth will come from new 5G enabled, typically non-handset use cases and verticals. So there's a wide range of new verticals, fixed wireless access, public safety, artificial reality, industry, e-health, other enterprise private networks, also automotive and connected cars. And all these provide for new challenges and new business models for the industry. There is a forecasted and a huge potential upside for operators, mainly coming from a cloud and the edge services on top of these new 5G networks. So we can see here that towards the end of the decade, we have a staggering $700 billion worth of a business in mainly actually in associated services. But we see that even 2 or 3 years from now, all this growth will still be a relatively small proportion of the traditional telecom market. So these verticals are expected to pick up from the middle of the decade and then explode looking forward. Many of these new vertical requirements will be addressed in future 3GPP releases 16 and 17, that will introduce URLLC, NRV2X, NR-Lite. And also, we see that many of these cases, they don't require any legacy technology. So these are essentially greenfield deployments, and again, an opportunity for new players. So let's take one such a vertical as an example, that of a digital industry. So Industry 4.0 is considered one of the major markets for actually being able to monetize 5G. And there's a wide range of emerging use cases on this continuum of between the EMBB, high bandwidth application, and the URLLC, low latency communications. So there are many, many use cases. Also, we expect in release 17 the introduction of NR-Lite. So this will address mostly the use cases in this mid-range in between, including industrial sensors and the video surveillance. So I think it is important to understand the value chain for this market to assess the potential for a new silicon. And the 5G for industry is much more than providing 5G links. It involves dedicated services and edge computing, and it is estimated that 75 billion worth of associated service revenues will happen towards the end of the decade. So this pool will trickle down the value chain and will create demand for dedicated and cost-effective silicon serving this market. We see a projection of 350 million digital annual connections in the industry towards 2030. But as we see, it has this hockey stick curve, which is typical for many of the forecasts of the 5G verticals. So the market essentially is practically non-existent now, but it is set to explode. So we expect new silicon development opportunities starting soon. So here is where our PentaG platform for a mobile broadband can be put to use. So first, let's touch briefly on the challenges associated with developing these 5G NR baseband modems. So we have the high performance requirement, but at the same time, it must be power optimized as many of these devices are battery operated. The architecture must also be support multimode, sub-6 gigahertz, millimeter waves, 5G, LTE, multiple decoding chains, diversity of target applications, and the architecture must be generic to support the evolving standard. It also needs to be flexible to accommodate key 5G functionality and algorithms like massive MIMO, advanced beamforming, and complex link adaptation schemes to sustain these high throughputs. But I think what is most important is that one needs a solution that is not only based on a DSP. A DSP solution by itself is not viable due to power inefficiencies. So one needs a comprehensive platform. In many cases, customers would accelerate the modem data path by hardware, which leaves the vector DSP to handle the many control channel estimates, a lot of operations involved in this modem. So you also need a flexible and low latency PHY control function. So these conflicting needs of extreme high performance and power efficiency requires a comprehensive set of IPs and flexible hardware-software partitioning. And that is exactly our PentaG IP platform, which is now the world's most advanced 5G NR IP for broadband connected devices. So PentaG offers an optimal and balanced hardware-software partitioning and it contains a wide set of components. It is, in fact, a complete platform. So it contains a scalar and vector DSP cores, coprocessors. It has our AI NNCP coprocessor. It has hardware accelerators, and it also has associated software and libraries. So all in all, PentaG reduces the enormous complexity of designing 5G NR devices, and this reduces the entry barriers for newcomers. So what are the key aspects of the PentaG platform? First and foremost, it is based around the CEVA XC4500 vector DSP. So this is a field-proven DSP, which we also introduced to it new 5G ISA extensions, specifically designed to accelerate key functions in the modem. PentaG also includes a set of CEVA BX2 scalar DSP cores designed to address the high performance and ultra low latency demands of 5G PHY control. Additionally, we have the VMU, the Vector MAC unit, which is a coprocessor having by itself 64 multiply accumulate vector unit. And this is designed to handle advanced channel estimation measurements and offload processing from the CEVA XC4500 core to improve the power efficiency. Another aspect of PentaG is a set of hardware accelerators, including FEC encoders, decoders, FFTs, MLDs, and the likes. Another component is that of the NNCP AI coprocessor, which we see here, tightly coupled to the 4500. So this one is designed to handle advanced beamforming techniques and link adaptation using neural networks. But PentaG is not only about hardware IPs or IP components. It's also it's a holistic framework, and it allows for it has a very a sophisticated system-level simulation, which is an integrated C-level environment that allows system engineers and architects and software developers to model, profile, and debug the system. So it has models for all the components that I've just discussed, and I will elaborate on that further in the upcoming slides. PentaG is also accompanied by software libraries for DSP communications and the specific 5G libraries, as well as complete reference chains like that of the PD CCH receiver. So here we see the PentaG's software interfaces. So we see here that the software is being developed on the both the CEVA BX2 for control and on the PentaG baseband module, the XE4500. Both can run FreeRTOS. And we have these communication links between them. So first we have this fast data transfer, typically using auxiliary AXI connections, wherein the cores can directly access local memory on each other. And we have these control operations, wherein typically the state machine of the modem would run on the BX2 processor, and this will activate and schedule tasks on the baseband module here. So essentially the BX2 processor regards this baseband module as a set, like a set of accelerators, and it orchestrates the operation of the entire system, also configures data transfer of the DMAs. So most of the control code would reside here on the BX2 processor. As for this system simulation environment, so the PentaG system level simulator is a powerful tool to model and simulate a complete platform, including any CEVA core, any number of instances of cores, customized hardware, standard buses, external and shared memories. So this is a C environment, and it also supports system C interfaces. And it can run the CEVA debugger environment for multi-core instances. So also a customer can easily add its own models. And debugging of these cores in the complete environment is as if real hardware is connected. So each of these components can run on the Windows C or directly on a target FPGA platform, and you can seamlessly switch between these two. There is also an optional support for MATLAB, so one can invoke PentaG simulation modules directly from MATLAB. Again, ideal for algorithm development and verification. So now I would like to show an interesting usage of this system simulation. So we see here how we hooked up the PentaG simulator with an OAI, Open Air Interface platform. So OAI is a known organization providing open source. This is like an alliance that provides software framework for complete core and access of cellular networks. So let's watch a demo of how we plug the PentaG into this OAI link. In this demo, we are showing our PentaG platform running on this FPGA system as part of a complete end-to-end standard compliant 5G link. The link is based on a OAI, Open Air Interface Open Source, which provides the GNB side and higher layers of the UE, while the PentaG platform here runs the L1 PHY processing. So let's get this thing rolling. Let me first establish the link. You can see the video starting to stream over this link of more or less 4.3 gigabits per second. Here you can see the OAI window showing the constellation and various other link parameters. As this is a flexible platform, we can also map to it different use cases. We have seen now a classic EMBB use case. And here you can see the PentaG platform load over time. And you can see the various PentaG submodules, activity and interactions. Let me now switch to a URLLC configuration, which is more suitable for industry applications, as soon to be ratified in the 3GPP release 16. This one meets a much stricter latency requirement. And you can also see how the load of the PentaG changes with faster reacting transactions. Okay, so you can find this video on our virtual MWC website, among other demos, interesting demos as well. So as we've seen, this we offer this integration of the PentaG to the OAI link as a reference to our customers. So let's touch briefly on the underlying cores and coprocessors in the PentaG platform. First is the XE4500 vector DSP. So this DSP is actually at has a bit of what we see as a sweet spot form factor for 5G applications. So it has been targeted by our customers for both the UE side and the infrastructure side. It has a 64 Mach vector unit, and it uses a highly power efficient pseudo floating point arithmetic. The core also uses, we added a specialized instruction set for 5G using the CEVA extend feature. And we have the CEVA Connect, a very advanced data transfer and memory subsystem. So this is a silicon proven with many licensees, and we have many in mass production as well. Next, we have the CEVA BX2 for PHY control. So that's where we run all the 5G sequencing and control that requires low latency and low power. So the CEVA BX2 is unique in that it is a combination of an excellent controller by itself, but it also a DSP, and you can use this small scalar DSP for doing all sorts of operations and measurements for power control, CSI calculation, HGC calculation, many operations that do not require necessarily a large vector unit. So this allows a flexible code placement between the vector and scalar cores. BX2 has a very competitive core mark, a benchmark of 5.5. It also it's very good in code compactness, and it also enjoys all the CEVA architecture goodies, the CEVA Connect, the extend features. So it's very easy to integrate the BX2 with other CEVA IPs, and it's a benefit to have a unified development environment across the entire platform. Another important component is that of the VMU, the vector MAC unit. So that is a programmable coprocessor, also equipped with 64 multiply accumulates, and this unit can work in a SIMD fashion. So this was designed to meet all sorts of advanced schemes for a channel estimation, and it is also, in fact, a generic engine for matrix processing that can be used in beamforming, for example. So using the VMU significantly improves the power efficiency when dealing with the math-intensive tasks that do not need the full flexibility of a vector DSP. We also have a very unique and innovative offering with the NNCP AI processor. So this one was optimized for executing neural networks, and we can show how we can intelligently optimize key 5G modem performance metrics by running neural networks that can achieve an optimal solution that is almost impossible to do with standard computing. Again, running this on this coprocessor significantly improves the power efficiency of these operations. And this is in fact the NNCP is a powerful and flexible edge computing engine for anything that is fire-related AI. And we see now in the many investigations in the academy and the industry of doing things like Doppler estimation, beamforming calculation, AI in DPDs, resource allocation, interference mitigation. So all in all, this can be a very useful engine for developing advanced phi-level algorithms. So let's see a few use cases and examples of how a PentaG can be employed to implement use cases for such as a UE terminal and also a GNB small cell. So here we can see the PentaG multimode architecture reference platform. You can see that the baseband module having the, including the 4500, as well as these coprocessors, the VMU and the AI processor that I've discussed. We also have a cluster of BX2 PHY controllers and this set of accelerators for a complete IP platform. And we can see that how one would do hardware-software partitioning on this kind of platform. So typically, one would sort the algorithms according to what requires high flexibility, which would run on the XE4500 and BX2. What requires less flexibility, which would typically run on the coprocessors, the VMU and the NNCP, and what is fully hardwired, like FFT operations, FEC. And we see this receive chain that typically starts with the full hardware acceleration, and then after the FFT, the signal is processed by the 4500 core that is doing the channel estimation and the control channel detections, also doing all sorts of CSI reporting and beamforming operations, and eventually the completed demodulation of the data channel is completed in hardware. So we provide a detailed and complete analysis for our customers. So when they ask us for a specific use cases, we help them in dimensioning this scalable platform and in allocating the task and the profiling and doing this initial proof of concept for the reference architecture. Similarly, one can use the PentaG for infrastructure side use cases. So here we can see the PentaG doing an all-in-one small cell configuration. Again, here we can see that the platform is scaled up to have 4 XC4500 cores, but also we can use this platform to implement radio units. Here we can see a radio unit that has a 4500 DSP for doing beamforming, but since in a radio unit, the processing is less complex, so in this instance, we don't instantiate the scalar BX2 cores. So to summarize and putting it all together, the PentaG is an SDR IP platform for 5GNR baseband processing. It is very flexible and scalable to handle multi-use cases from UE to infrastructure. It's a comprehensive IP platform having many hardware components and software libraries. It is scalable to address all sorts of use cases, and not least important, it has this system level simulation for a holistic integrated development environment. So this concludes this brief introduction to the PentaG platform. Thank you for this opportunity.